interact with the universe around us, we depend on our memory. This, in turn and by definition, depends on time. What is not remembered does not exist, even if it is there. For its part, the universe does not seem to be very concerned with what we think about it, staying out of the process. Although the universe is probably one, each observer has his own time to observe it. That is, my universe is probably being observed from a particular and unique moment of time, different from the time when the spectator himself evaluates it. If two objects cannot occupy the same place in space, they are likely not to occupy the same moment in time either. In any case, if the universe were static, it could not house time or movement. The present would be an eternal moment. Thus, a memory-minded observer could not conceive of the existence of a place without time, even if it existed. There are some indications that suggest that, perhaps, the universe could be structured on only two dimensions. One such clue is the concept of outcome of the future of any event. For example, alpha of the centaur, according to estimates, shines in the sky 4.3 light years from where we are. For astronomers, the light from that star would shift into space in the form of concentric circular waves, all departing from the source at the same speed. Stephen Hawking compares these waves of light to those that would be formed on the two-dimensional surface of a lake, where a stone was thrown. If you add to the aforementioned model the one dimension of time, he tells us, the waves would overlap each other, resulting in the formation of a three-dimensional cone, whose vertex would be constantly occupied by the star. Note that time would be the cornerstone for the lake surface, to gain depth. That is, time would assume the third dimension of space, because without time there would be no depth. Another indication of the existence of the static universe is that the observer, even having been expelled from there, would still remain above the center, without depending on his position in space. Always being on the center is one of the characteristics of a two-dimensional surface. If you could move to the center as alpha, you would take the zero time with you. From that point on, and by always remaining in the present of the universe, you would assume that, if Earth reflected enough light, would be seen as it looked 4.3 years ago. One might think that the center of the universe should not be a special place you occupy, for depending on the point of view, all visible stars would occupy their own center. The difference is that the observer is the only one with a conscience, and the only one who can express his point of view. The moment you do, you have the vivid impression that you would be at the center of the universe. In the case of stars, even if they were also on the two-dimensional center, they could not know that. Taking our views into consideration, I tried to make a recipe in which the ingredients would consist of planets, moons, galaxies, and the like. Writing a theoretical model for the universe is not unlike making a new cooking recipe. We hope it works, but you're never sure. To illustrate this first step of the recipe, I will cite the book of Genesis, in which the author of that text already foresaw the intimate relationship between light and space. God said, "Let the light be," and the light was made. It may be noted that, at first, the light and darkness were together, but the light could not manifest itself. And God saw that the light was good, and divided the light from the darkness. The word darkness could be replaced by the words vacuum or space. I believe that this separation would bring, within itself, the very curvature of space. That is, while God had made light an independent entity, he would have to have curved space forever. The coding of information would make light assume the function of being the messenger of space. We must remember that all matter results from the condensation of energy. Apart from the above coding process, space could not directly communicate any changes in its geometry. To do so, it would be dependent on its messenger. When separated from space, light would need to be packaged or quantized, because in its two-dimensional nature, it would not have its presence revealed to the observer, whose memory would be time-dependent. That is, time would act as if it were a third dimension. In this case, the concepts of time and depth of space would be mixed. Here we could cite the light cone of the future of any events, which would result from the theoretical superposition of light waves emitted by any source in the time that separates them from each other. When space curved due to the bundling of light, it would be necessary to retain the total time that was allocated to the aforementioned process. Since this would prevent the waves from overlapping, it would be evident that the third dimension of space and the cone of light would be confused with time itself. Depth, in this case, would be a consequence of the direct measurability of time, which is only delayed, or after the scattering of quantized light, at the observer's position. If the quantization time were retained in any way, even if the space curved, it would remain virtually two-dimensional at the level of its messenger. There would be a fusion between space and light itself. Whatever happened to one of them would be reflected in the other. This includes the very continuous curvature of space, which becomes real when the arrow of time is reversed in our position and light is projected into our past. As a result of the fusion of light and space, everything in the space-time universe would continue over the center, which, I insist, is a feature of two-dimensionality. Ground zero, which was once in the stars, would have definitely migrated to the position of every single observer with a memory. He would take this milestone with him without depending on the place occupied in space. Since being on the center is also one of the characteristics of the static universe, it would also have to be valid for three-dimensional space-time. This suggests that our brain would have been prepared to carry the two-dimensional reality, in the form of information, into the realms of our consciousness. The third dimension of space would be a kind of simulation related to time. That is, because it is contained within ourselves, by a principle of exclusion of direct access to what would be in our future, time would be a form of exile, to which we would be subjected by our own memory. For us, there would only be the inside of this prison, and there would be no way out of it, souls, to know if there was anything outside. Since the packaging of light, our photon, is delivered ready to us by nature, without any time wasting, the absence of time in the future does not allow us to predict the existence of moving light waves within the future light cone of events. Newton's laws were not designed to function in the absence of measurable time. That would explain the instantaneous way how we look at the celestial ball. If the light of a star would have shifted at an earlier time, that would not be part of our physical reality. In fact, when it comes to our point of view, and just in this case, the light of the stars has always been available to us on Earth, to be followed only in the direction of our past. This would occur through a form of remote tracking. The above description tells us that the light of the stars that had not yet reached us on Earth would be undergoing a polarization process in full packaging phase. For example, in the case of visible light, the extremes occupied by ultraviolet and infrared would be so close to each other without touching that the time separating them could not be directly measured. This is what happens at the subatomic level of matter, where time tends to zero. This tendency remains suspended at infinity to preserve the uncertainty of the position or velocity of the particles. None of this would make any sense if our brain's neurons had not been prepared to assimilate time as soon as the light spread after the collision between the quantum and free electrons, and these neurons, apparently, seem to vibrate continuously. Our brain, in this case, need not create an alternative form of reality. It would only perform the function of transporting reality, in the form of information, into the realms of our consciousness. In this movement, the real or primary universe would be left out, even if we knew that this universe would have no sides. The concepts of future and present merge into one thing. Since things cannot be seen in real time, or need to be enlightened beforehand, the future results from the paradox of always looking to the present of the universe with delay. Although it is only a particular point of view, I cannot help but notice a certain intentionality in this whole process. When we point our telescopes toward the celestial vault, in an attempt to capture only what is outside, we end up neglecting the reality that would be escaping our senses and asking to be better explored. To feel it, we need introspection, or a closer look inside ourselves. Without it, we are getting colder and without prospects, moving farther and farther from the present. But everything has its right time.